Graphing quadratics, max and min. We're going to start with graphing quadratic function recap. So the first thing we're going to do is we're going to figure out the vertex. And when we figure out the vertex, we use the equation x equals opposite of b over 2a. And that finds us our axis of symmetry. So in this quadratic equation, a is a -1, b is a -6, c is a -5. So to calculate the vertex, or the axis of symmetry, it's going to be the opposite of -6 over 2 times -1. +6 over +2 is 3. So my axis of symmetry is x equals 3. That means I'm going to come over to my graph and I'm going to put in a vertical line at x equals 3. And I know that the vertex of my quadratic or my parabola will be somewhere on that line. And now I'm going to figure out where that is. So I'm going to take the x equals 3 and plug it into the equation and find y. Y equals the opposite of 3 squared minus 6 times 3 minus 5. Pay attention while you plug the value in for x. You will always square before you multiply by anything in front. So that's going to be the opposite of 9 minus 18 minus 5. Okay, I made a mistake. This is supposed to be -3. And the reason that it's a -3 is because it's 6 over -2, which is -3. So that's -3, and then that changes this just a little. That's still going to be a -9, but it's going to be a +18. And so that's going to be 9 minus 5 is 4. So now we have our vertex at -3, 4. Is the vertex a max or min point? All right, the vertex is a max point because a is less than 1, okay? Parabola opens down. What is that max or min value? Well, this is the y value of the vertex. So that's going to be 4. How many roots or zeros are they? Well, that is another name for the x-intercepts. So let's graph it so we can see how many x-intercepts there are. So we know the vertex is at -3, 4. So I have to fix my axis of symmetry. Plot my point. And now I need to figure out 1 or 2 more points on the graph. The y-intercept is always a good point. The y-intercept is always C. So C is -5, so the y-intercept is 0, -5. Okay, use that point to find the mirror point over the axis of symmetry and graph your parabola. And so we see now that the parabola goes through the x-axis twice. So that means there are 2 x-intercepts, which means there are 2 zeros or 2 roots. And then it says, what are these solutions, which is another name for roots or zeros. So that means we need to solve the quadratic. Okay, so that's going to be 0 equals -x squared minus 6x minus 5. Now, I don't want to solve with a negative in front of the x squared, so I'm going to factor it out. So x squared plus 6x plus 5. I'm going to factor x plus 5, x plus 1. two numbers that multiply to be 5 and add to be 6. Then I'm going to set each of those equal to 0. And so -5 and positive, or a -1. And that does appear to make sense if we go back to our graph. -1 and -5 are almost exactly where I went through the x-axis. And that is a recap of graphing a quadratic or a parabola. Now I want you to notice up here, it says caution, the minimum or maximum value is the y value at the vertex. It is not the ordered pair that represents the vertex. So that's super important that you answer it correctly. So what is the max or min value? It is the y value of the vertex. Okay, let's go on to our next slide, and let's talk about max or min applications. A projectile, so these are called projectile motion applications. A projectile is an object that rises and falls under the influence of gravity. And projectile motion is the height of that object as a function over time. So let me highlight that. Projectile motion is the height of that object as a function of time. Projectile motion is modeled by quadratics, and that is why we do it now. Projectile motion involves objects that are dropped, thrown straight up, or thrown straight down. Factors that influence the height of these objects include the height from which the objects are dropped or thrown, whether they're thrown up or down, whether velocity is involved, and of course, the pull of gravity downward on the object. On Earth, the acceleration due to gravity is approximately 32 feet per second, or 9.8 meters per second squared. Here's the general formula for a projectile motion problem. Identifying over on the right what each variable in the equation represents. Also, you will see the equation like this: h equals 1/2 at squared plus v sub 0 t plus h sub 0. So in place of the y and the y sub 0, you will see h and h sub 0 to refer to the height. T is time, A is acceleration due to gravity, V sub 0 is the initial starting velocity. These would all be given to you, as would the general formula be given to you. Go to your next slide. Let's begin with objects that are dropped, okay? If an object is dropped, it is simply released and not thrown. There is no initial velocity other than the pull of gravity. This means that the middle term of the formula is not needed, since v sub 0 is 0. We will now be using h to represent the height, as it is easier to remember its meaning, and h sub 0 to represent the initial starting height. If we are working in feet, the acceleration due to gravity is -32 feet per second. Gravity pulls the objects toward the earth, making the value negative. The formula to model the height of an object t seconds after it has been dropped is -16 t squared plus h sub 0. If you're working in meters, that coefficient of the squared term, the t squared term, changes. Again, you do not have to memorize these. So let's start with an example. Carmine drops a ball at shoulder height from the top of a building. If the ball is at rest and is simply dropped, how long will it take to the nearest tenth of a second to hit the ground? So notice that the units are in feet, and so we're going to use the equation h equals -16 t squared plus h sub 0. Notice it says, how long will it take to hit the ground? Okay, well, if the ball is hitting the ground, then the final height of the ball is 0. t squared represents the time, and we're going to solve for that. H sub 0 is your initial height. And so you go and look in the diagram, and you see that Carmine is 5 feet tall at his arms. The building is 35, so that means together the initial height is 40. And now we're going to solve for t. And we're going to solve by square rooting. All right, so I'm going to subtract the 40 over, divide by negative 16. I'll grab my calculator. So negative 40 divided by negative 16 is 2.5, and that equals t squared. And so we're going to square root both sides. And normally when we square root, we do plus or minus. But I'm going to put a star here and say no negative time values. So we won't do the plus or minus of the square root of 2.5. So square root of 2.5 is 1.58113883. And the problem said round to the nearest tenth. So the tenth is right here. The 8 rounds at 5 up to a 6. So 1.6 seconds is your answer. Okay, let's look at the next example. Objects that are thrown. If an object is thrown, a certain amount of initial velocity accompanies its launch. Now we have a reason to use the middle term from the general formula. We will continue to use h and h sub 0 to refer to the height. Okay, so notice the new equation. It's got a middle term because the middle term has a coefficient of that initial velocity. A model rocket is launched straight upward. The solid fuel propellant pushes the rocket off the ground at an initial velocity of 200 feet per second. All right, so let's go ahead and fill in our equation. H equals, and it's feet, negative 16t squared plus 200t plus, a model is launched straight upward, and it pushes it off the ground. That means the initial height is 0. When will the rocket reach a height of 336? Okay, so when is h equal to 336 feet? That's our first question. All right, so let's plug in 336 for h. Put it in standard form. So now we're going to solve this quadratic, all right? Let's first start and see if we can take out a GCF, right? So, if we took out a 4, a negative 4, that would be 4t squared minus 50t plus 84. Now we could try to see if it factors, or we could go straight to the quadratic formula. It's up to you. I'm going to go straight to the quadratic formula, but now I have smaller numbers to work with. So t equals the opposite of a negative 50 plus or minus the square root of negative 50 squared minus 4 times 84 all over 2 times 4. So again, once you pull out the GCF, you don't need to use it in the quadratic formula. So I'm going to go to my calculator. Okay, so I have t equals 50 plus or minus the square root of 1156 all over 8. So let's see if 1156 has a square root. It does. It's 34. So t equals 50 plus or minus 34 over 8. Now, since t represents time, we know that there's only going to be one answer there, right? So that's going to be 50 plus 84, not minus, or actually 50 plus 34 divided by 8. That's 10.5. But what if we do 50 minus 34 divided by 8? That's 2. Why are there two answers there? Well, the reason that there's two answers there is because this rocket hits the height of 336 at 2 seconds and then again at 10.5 seconds, because it hits that height on the way up and then it hits that height again on the way down. What is the maximum height reached by the rocket? All right, so maximum height. The maximum height is going to be the vertex. So we're going to go back to what we did at the beginning, and we're going to find the axis of symmetry. So that's x equals opposite of b over 2a. And now you can go back and use your original equation, or you can use the factored one. I'll go back to the original. So that's going to be the opposite of 200 over 2 times negative 16. Reminding you that when you put this into your calculator, I would use the green alpha button and then the y equals so that you can type it in as a fraction. So alpha y equals, you're going to put negative 200 on top. On the bottom, you're going to put 2 times negative 16. And it turns out to be 25 over 4. Which is 6.25. Now the question said, what is the maximum height? X, and I should have used t, because we're dealing with t. T equals 6.25 is the seconds that the rocket goes before it hits the maximum height. So at 6.5 seconds, the rocket hits the maximum height. To find that maximum height, you have to plug that 6.25 back into the equation. So you're going to get h equals negative 16 times 6.25 squared plus 200 times 6.25. Okay, so that's going to be negative 16 times 6.25 squared plus 200 times 6.25. And that maximum height is 625 feet. Okay, part C. You forgot to put the parachute on the rocket. When will the rocket hit the ground? So 0 equals negative 16t squared plus 200t. So when will the rocket hit the ground? The ground is always 0. The ground is always a height of 0. I'm going to solve this time by factoring. So I'm going to factor out a negative 4t. That's going to leave me with 4t minus 50. I'm going to solve each of those equal to 0. So negative 4t equals 0 and 4t minus 50 equals 0. Now the first one is t equals 0. Well, that makes sense because the object starts on the ground. So the height of the object is 0 when time equals 0. How long is the object in the air? I'm going to solve for the second t. So 50 divided by 4 is 12.5 seconds. Okay, and those are all the different questions that you can ask when you're working with projectile motion. All right, let's try 2 more examples and then I'll have you try some. A company is selling headphones. If the company models the price using the following function, what is the maximum profit the company can expect to earn? So maximum profit means you're going to find the vertex of this parabola. Now, in order to find the vertex, you should always make sure that the parabola or the quadratic is in standard form. So in other words, ax squared plus bx plus c. This one is. And so we're going to go ahead and begin our calculation. So x equals the opposite of b. So b is 700 over 2a. So that's negative 700 over negative 20. That's 35. Now notice it says, what is the maximum profit? We found x, but the maximum profit is the y value of the vertex. So I have to plug that 35 in. So I have to do f of 35 equals negative 10 times 35 squared plus 700 times 35 minus 6,000. So 35 squared times negative 10 plus 700 times 35 minus 6,000. So it's 6,250. And you can go ahead and test it in the box. All right, example 4. A small drink manufacturer has a daily production cost of the following, where C is the total cost and X is the number of units produced. How many units should be produced each day to yield a minimum cost? How many units to yield a minimum cost? So we're looking for X. So what is X in the vertex? Because the vertex is either a maximum or a minimum. And in this case, it's a minimum. Put your quadratic in standard form. And there's a typo there. That should be x squared. So that's going to be 0.075x squared minus 120x plus 70,000. And we're going to go ahead and calculate the vertex. So x equals the opposite of b over 2a. Whoops. Be very careful when you type it in your calculator that your calculator is calculating 2 times 0.075. So this is 120 divided by that product. Which is 0.15. If you type it in your calculator, 120 divided by 2 times 0.075, it's going to do the divided before the multiply. 800. And then it said how many units, and so we're done because we have found the number of units. Okay. Marco is at Topgolf and he hits a golf ball into the air from the 3rd level that is 48 feet high, giving us the following equation. What is the height of the ball when it hits the ground? The height of the ball when it hits the ground. That means when will the ball hit the ground? Okay, sorry, I didn't read that correctly. When will the ball hit the ground? So the ball hits the ground at a certain time, but the height of the ball is 0. So 0 equals negative 16 t squared. Okay, I'm going to factor out the GCF, which is negative 16. T squared minus 2t minus 3. I'm going to factor. Now, it doesn't always factor, but this is a simple one. So we're using our solve by factoring technique. We know we can't have negative time, so after 3 seconds, the ball hits the ground. Okay, so let's try these two. The number of horsepower needed to overcome a wind drag on a certain automobile is given by this. Okay, so our equation's already in standard form. The first question is, How much horsepower is needed to overcome the wind drag on this car if it is traveling 50 miles per hour? So 50 is speed. So the first thing I'm going to do is I'm going to calculate N of 50, which means I'm going to substitute in 50 for S. Okay, there's lots of decimals here, so be careful when you type it into your calculator. Okay, 12.8. Because it says, you should round to the nearest tenth. Okay, so let's round to the nearest tenth. At what speed will the car need to use 200 horsepower to overcome the wind drag? So notice it says at what speed. So now I'm finding S where 200 is N. So I'm going to come down here to calculate that, okay? So 200 equals 0.005 S squared plus 0.007 S minus 0.031. All right, I'm going to subtract 200 from both sides, and I've got 0 equals 0.005 S squared plus 0.007 S minus 200.031. And now I'm going to do the quadratic formula. So S equals the opposite of B plus or minus the square root of B squared minus 4 times A times C all over 2A. And now you should go ahead and type it into the calculator. Now you can only type in one at a time. So you have to start by typing in the plus first and then the minus second. So negative 0.007 plus square root parentheses 0.007 squared minus 4 times 0.005 times negative 200.031. And then that gets divided by and so it turns out to be 199.3. Then I'm going to put in the minus 1. But when I put in the minus 1, I'm going to have a negative in the numerator divided by a positive, which is going to give me a negative, and we don't have negative speed. So this is my final answer. Okay, next one. A manufacturer of tennis balls has a daily cost. Okay, it's still not in standard form, so we're going to put it in standard form. You put it in standard form so you can identify your A, B, and your C correctly. Okay. What number of tennis balls will produce a minimum? So we're looking for the vertex, right? And it says where C is the total cost and X is the number of tennis balls. What number of tennis balls means we're finding X. So that's one step calculation, opposite of B over 2A is 500. All right, 2 more here, and then I believe those are the last ones. Manufacturer of light fixtures has a daily production cost, where C is the total cost and X is the number of units. How many units should be produced every day to yield a minimum? To yield a minimum, that means we're finding the vertex, and it says how many units, that means we're finding X. So x equals, and let's put it in standard form up here. So 0.25x squared minus 8x plus 800. So opposite of b, so opposite of negative 8 over 2 times 0.25. So that's going to be 8 divided by 2 times 0.25. And that's 16. And then our last one, again, we're already in standard form. Company earns profit, so P stands for profit. We're selling X items. How many items? Always look for the question. Does the company have to sell to maximize? Whenever you see maximize or minimize or max or min, you're looking for the vertex, and we want to find X. So X equals the opposite of B over 2A. So let's type that in, negative 40 divided by, and I tend to then put parentheses around my denominator. So 2 times negative 0.5, and that equals 40. So they have to sell 40 items. I think that's it.